Good morning, Cleverson.
Hello, good morning.
Are you speaking? Because I cannot hear you.
Hello. Hello. Hello, can you hear me? Hello, hello, hear me?
Perfect. I can hear you now.
Okay,
I'm sorry, it was a problem on my side. So I do hope other people will connect because as of now, you're the only one connected to the room besides me.
okay,
We are supposed to have 5 papers presented in this room. So let's wait a little bit more. Okay?
okay.
Okay. Thank you. Okay, Cleverson. So I spoke to the organization and we should start because otherwise there would be too much delay. So I will stop sharing the break page now. Okay. And for if there is anyone following on YouTube, now Clever Sonvera is going to present his paper, Integrating Counterfactual Evaluations into Traditional Interactive Recommendation Frameworks. So please, Cleverson, you can go on.
Okay, I'm share the presentation.
Okay. Okay, I can see it.
Good morning. Initially, sorry for my bad English and forgive me for any mistakes, please. The title of this paper is Integrating Counterfactual Evaluations into traditional interactive recommendation frameworks. My name is Cleverson Vieira, a student at Federal University of São João del Rei in Brazil. This presentation is divided into 5 talks: introduction, tools for NIB models, our proposal, experiments, and conclusion and future works. Several web applications have invested in recommendation system to guide entry user experience from their first interactions as a sequential decision model. Recommendation system play a crucial role in various web services, effectively identifying and suggesting relevant items for individual users. Examples: movies in Netflix, products in Amazon, publications in Facebook, points of interest in Yelp, and others. Online recommendations pose several challenges: multi-armed band problem, evaluation metrics variability, offline evaluation versus online evaluations. Several research studies have proposed a variety of frameworks to assist in evaluating recommend system algorithms. We observed 2 complementary frameworks that allows to evaluate band solutions more accurately: IRAC and Open Bandit Pipeline (OBP). The first is a complete set of dataset, metrics, and map models implemented, allowing only offline evaluations of these solutions. The second is limited to a few bandit solutions with more current metrics and methodologies, such as counterfactuals. The IRAC is a framework proposed to enable the use of interactive models based in map models in the recommendation domain. Some features this framework: public data sets for diverse applications, distinct bandit models from the literature, several offline evaluation metrics. IRAC is composed of the 3 main components that cover the whole experimentation process: the construction and environment, the definition of the recommendation agent, and the definition of the experimental evaluation. The environment component configures the data structure, and IRAC has 17 public data sets for various scenarios. The recommendation agent component select the model to define the best item for each user. Finally, the experiment evaluation component integrates the proposed models over specified data. The OBP is a library that includes some models to implement pre-processing of data collections and various recommendation methods. The library attempts to deal with the bias of existing database for the recommendation scenario. Features this library: synthetic and real-world data, policy learned by logged data, several online evaluation metrics. We can see the overview of the OBP library with its 4 main models. The data model provides a mechanism to work with data collections from the load step to generating synthetic data. The policy model enables implement new bandit methods and evaluation policies. The simulation model allows offline simulation of bandit models for performance evaluation. The evaluation policy model offers customizable interface from implementing estimators. There is not a consensus on evaluating interactive recommendation models. IREC and OBP are essentials and have combined potentials. This work proposed an integration between an IREC and OBP to perform a complete analysis of requirements implemented as a map model. This tool offers an approach for data preprocessing, lean method selections, and comprehensive evaluation using traditional metrics and counterfactual estimators. The unification process between the frameworks is separated in three main modules. And one, the data construction; two, the simulation of the requirements; three, the experimental evaluation. In the data construction model using OBP, data for experiments are prepared, including synthetic data creation and parameterization. We include new parameters for dataset construction, allowing flexibility and realistic simulation. IREC is used for train and test data separation. The second model utilizes the prepared data for train and testing recommended models implemented by IREC, offering various recommendation algorithms, including classical and deep learning-based approaches. In the last model, recommendation algorithms are implemented based on the generated logs divided into two groups: traditional metrics and counterfactual estimators. We can see the image with the integration between IREC and OBP represented. The configurations for using the tool are composed of several YAML files responsible for defining all the model parameters. The framework offers an API for integration with other softwares. We divide our experience between traditional and the confactual evaluator. Three data sets available by IREC were used: Netflix, Google Books, and Yahoo Music. We compared the performance of the following algorithm available in IREC: grid, UCB, TS, linear grid, and linear UCB, considering three metrics implemented by IREC: hits, ILD, and user coverage. This table, automatically generated by IREC, shows the experimental results. No methods got the best results for all metrics, showing the importance of using different methods suitable for the recommendation scenario. Linear UCB performs best in relevance reads, and linear and grid excel in diversity for Yahoo Music and Netflix, while the UCB performs better from Google Books collection. A synthetic recommendation dataset was created using OBP with rating from 1 to 5, similar to MoveLens. And three estimators were used to evaluate which recommendation system. Results show that linear UCB and UCB strategies perform well, consistent with traditional evaluation. This work filled a gap by integrating IREC and OBP frameworks for evaluating map-based interactive recommendation systems. The integration enables offline evaluation and counterfactual analysis with unbiased synthetic collections. And future works aims to expand the evaluation to include more neighbor models, metrics, and data sets. Our references are displayed in the paper. If I see you have any questions, please contact me. Thank you.
Okay, Cleverson. Thank you for the interesting presentation and also very clear, if I may say. So, is there any question from the public? If not, I have a question. So, I can see that in this approach, you created some synthetic data set, right, to integrate both evaluation methods. So, which were the settings you used to create the synthetic data set? Did you somehow mimic the real data sets you showed before in terms of number of users and the characteristics, or did they have different characteristics from real data sets?
Sorry, I understand my English is bad.
No problem. I said, so you created synthetic data sets, right?
Yes.
So, which are the characteristics of these data sets? I mean, how many users in the synthetic data set, for example? Can you hear me?
Hello, sim.
Okay. So did you get the question, or I can repeat? Okay, seems like Cleverson is having some problems. Okay, so I think if the problems cannot be solved, we can just move to the next speaker. And we thank again Cleverson for his speech. And the next speaker should be Pakiso Komokoana. Is he online?
Hello, can you hear me?
Hello? Yes, loud and clear.
And can you see me?
Yeah, I can
All
see
right.
you.
All right,
So,
thank you.
next speaker will be Pakiso Komokoana with his paper, A Framework to Assist Instructors Help Novice Programmers to Better Comprehend Source Code, a Decoding Perspective. So please, Pakiso, you're free to present.
All right. Can you see my screen? Hello, am I audible?
Yes, yes, yes. You're audible and we can see your presentation.
All right. Good morning, ladies and gentlemen. My name is Pakiso, and I come from the University of the Free State in South Africa. And the title of my presentation is A Framework to Assist Instructors Help Novice Programmers to Better Comprehend Source Code, a Decoding Perspective. Source code comprehension is an indispensable skill in computer science as a discipline. And literature defines it as the ability to read, interpret, and understand existing source code. However, many computer science students are still unable to reliably think and work their way through a long chain of reasoning to efficiently comprehend a piece of source code. And Johan Middendorf and David Pace, who are the pioneers of the decoding the disciplines paradigm, refer to this as a bottleneck. They define a bottleneck as specific places in the course or in the module or in the subject where the learning of many students gets interrupted. Bottlenecks can be intensified by, among others, the instructor's inability to accurately expose their unique ways of thinking in their own disciplines, as well as the instructor's expert blind spots. And these blind spots normally occur when the vital operations have become so natural to the disciplinary experts that they tend to omit the crucial mental steps when explaining concepts and procedures to others. And the decoding the disciplines is a paradigm that focuses on increasing student learning by bridging the gap between the thinking of novice and expert programmers. And as you can see on the screen, these are the 7 steps of the decoding the disciplines paradigm. And in step 1, which is bottlenecks to learning the top one, we normally identify the student learning bottlenecks. And in step 2, which is decoding expert thinking, we expose the nature of the hidden operations linked to a specific bottleneck and create awareness among instructors regarding the mental steps or operations that our instructors typically omit when teaching their students. And in the rest of the steps of this paradigm, the instructors are guided to devise ways of helping students to master these mental operations and hence overcome learning bottlenecks. And the work of this paper follows from the previous one that identifies source code comprehension bottlenecks. And as such, this paper focuses on step 2, as you can see it's marked there, which is where we explore the explicit mental steps that disciplinary experts follow to accomplish a task identified as a bottleneck. And in executing this step, which is step 2, there are various artifacts or techniques that are used. And the decoding interviews is one of the techniques, and it is cited as the most rigorous and effective technique. And what is this decoding interview? A decoding interview is a special type of interview where the disciplinary experts are intellectually guided to reveal the explicit steps they follow to get through a predetermined learning bottleneck. As such, the study was set out to identify the explicit mental strategies that computer science experts employ while comprehending source code, as well as to ascertain how the knowledge of these strategies can be applied in the formulation of a step-by-step framework that could ultimately contribute towards ways of assisting novice programmers to overcome their bottleneck. which in this case is an inability to reliably think and work their way through a long chain of reasoning to efficiently comprehend a piece of source code. And as I said previously, this bottleneck has been established in a previous study. Coming to the research design and methods, we followed a narrative research approach based on the frameworks for an integrated methodology by Playwright. And we collected narrative data through face-to-face decoding interviews. And our population was computer science instructors from a selected South African university. And we used a purposeful and convenient sample of 5 instructors. And 2 of the instructors had 14 years of experience teaching computer programming. And 2 had between 5 and 9 years of experience teaching computer programming. And 4 of them had worked as industry programmers for at least 4 years and were still involved in private programming work. Now coming to data collection, as I said, we used the decoding interviews. So we engaged a non-teaching computer science researcher who had some decoding interview experience, and I was the principal researcher. And of course, we recorded the proceedings of the interviews after we were given permission by the participants. And in collecting data, we collected it in 2 phases. And the aim of phase 1 was to uncover the explicit mental strategies and steps that are followed by participants during a source code comprehension task. And the task that they were given, each participant was asked to explain the generic steps he or she would follow when requested to predict the output of any piece of source code provided on a piece of paper. And this was done intentionally. We didn't want to use the IDE. And the outcome was that from the responses of the participants, we were able to get a first glance of some of the basic source code comprehension strategies utilized by expert programmers. And in phase 2, the aim was to uncover more explicit details regarding the nature of the shared strategies. And the participants were each presented with a source code comprehension task and asked to illustrate how they would implement their source code comprehension strategy or strategies as explained in the previous phase or in phase 1 to solve a given problem. And we also made sure that they used the think aloud technique. And this was the problem that was given to the participants. And as you can see, in line 1 is the signature of the assorted method. And the participants had to identify the missing source code so that this method should return true if the array is sorted in ascending order. Otherwise, the method should return false. And the correct option for this question was option B. And now coming to data, we analyzed our data thematically, and the outcome from our analysis was that we were able to develop the initial framework for answering a source code comprehension question. And from the initial framework that we developed, after developing it, we thought of validating the framework. And what we did was we had 2 phases of validation, whereby in phase 1, we engaged the second decoding interviewer who reviewed the initial framework that we developed. And we wanted him to confirm whether the identified strategies and steps were a true reflection of the data gathered during the decoding interviews. And we also asked him to check all the statements for clarity and ambiguity. And of course, from his feedback, we were able to make more revisions to the initial framework. And phase 2 of our validation, we arranged a validation meeting with the aim to validate the implementability and usefulness of the framework. And this time around, we also had 5 participants, 1 computer science junior lecturer, 1 a computer science postdoc student, and 3 computer science professors. And these were different participants from those that we involved in our data collection. And each participant was, the participants were requested to follow the framework steps or the steps of the framework as closely as possible while answering the 2 source code comprehension questions. And these questions, we had used the questions that were developed by Lister et al. I hope most of us in this venue are aware of the work that Lister and colleagues did in this area. So we used their 12 multiple choice questions. So for the validation purposes, we used questions 1 and question 9. And what we did here was that we explained how the model works to the participants. And after that, we gave them 2 problems. And the first problem was whereby we asked participants to work on question 1. And they worked on question 1 under our guidance, following the steps in the framework. And now, when that was done, we asked the participants to work independently on the second question, which was question 9. And this time around, they worked independently, following the steps of the framework. And after that, then there was an open discussion whereby they shared their experiences in answering these 2 questions, as well as some of the things that they had with the model or the framework that we developed. And of course, the intervention or based on the feedback received during the validation meeting, we made some changes to the initial framework. And ultimately, we came up with this framework. So this is a step-by-step framework for answering a source code comprehension question. And what we did here was that we looked at the strategies that our participants were applying when they were answering these questions. And some of these strategies come from the literature. And most of them are strategies that have been identified by Fitzgerald and our colleagues. So what we did was we took the 4 strategies. We have self-orientation, keyword identification, strategic thinking, and revisiting previous stages. And then we looked at what our participants were doing there. And we were able to classify that as understanding the problem. So the things that they were doing when they were applying these strategies, we could see that our participants were trying to understand the problem. And then in understanding the problem, we are suggesting that people should read through the question statement or requirements at least twice until you understand what you have to do. So these are the things that we saw with our experts, that they were at least reading the question twice. And in doing that, you can highlight or mark important words and or phrases and make sure that you understand their meaning or implication. And now, if there are any words or phrases that you don't understand, consult any additional resources for clarification. So The additional resources could be the internet, could be the textbook, they could be the lecturer or the internet. And if I were to write the code to solve the problem, how would I do it? So this is the description of the first step, which is understand the problem. And then we also looked at some of the things that they did under self-orientation and when they were revisiting previous stages. And we were able to classify that as scanning through the code. So as you can see, we have about 10 steps there. So you will have to scan through the code, not recognizing syntax. And then step 3, you scan through the code, now recognizing syntax. And then step 4, you seek clarification. Step 5, you use context. Step 6, you confirm your understanding. Step 7, you scan through the code, not recognizing syntax, because here you just want to confirm. And then you deal with multiple choice questions, and then you trace and execute the code, and then you report your result. So as you can see, this is the model that we developed. And then the thinking that we followed was, we looked at the strategies that our participants applied, and then we were able to group that into this step to say, for the third step, we have self-orientation, data structure identification, strategic thinking, walkthroughs. So we were able to classify that as scan through the code. So as you can see, this is the model that we developed. And in conclusion, we want to say the gap that exists between the ways in which novice and expert programmers comprehend source code continues to be a challenge. And by focusing on step 2 of the decoding the disciplines paradigm, we use the decoding interviews to systematically deconstruct the mental operations performed by expert programmers while comprehending a piece of source code. And given the nature of the source code question used as an example and the previous experience in programming subjects, it is worth noting that most of the strategies described by Fitzgerald and colleagues and in this paper are very imperative oriented. And we have also identified that each programming expert approaches source code comprehension differently. And at any stage during the source code comprehension process, experts' prior knowledge or experience can trigger them to use specific strategies. And experts also find it easy to switch to a completely different strategy based on what they are currently thinking and the information or details that they are encountering. And on this note, I would like to thank you. Danke, Kialeboha, Efkaristo. Thank you. Hello.
Well, thank you very much, Paquito, for your interesting work.
Thank you.
I particularly appreciated the way you formalized the interview process and the two-step data gathering. So that's really interesting. And I would like to ask the public if there is any question. So if not, I have a question for you.
All right.
I can see, so in the conclusion, you mentioned that you are going to perform further research on the matter, right? Because still it's challenging to understand how do programmers interpret source code, right?
Yes.
But still, are you planning to test your strategies and the findings of this work in a real environment, let's say with students who are learning how to program actually, to see if they can benefit from that?
All right, thank you for your question. Definitely, we are going to test this model because now, as you can see, if I'm to go back to the model, This is a step-by-step framework for answering a source code comprehension question. So in other words, in testing this model, or expanding on this model, we can even improve on this model to say, let's not be specific on a source code, on answering because here we were specifically concerned about multiple choice questions or answering multiple choice questions. And then now we can even expand this model to say, now if you have a source code comprehension question, but this question is not a multiple choice question, how can this model help, or how can we modify this model to cater for that? And then now also going back to this paradigm here. So what we did, as you can see, we have 7 steps, whereby in the first step, we identified the bottlenecks. And then the second one, we try to see how experts would do these things. So we are still carrying on to see how can we model, how can we help the students, how can we give a practice and feedback to students, how can we motivate the students, how can we assess, how can we share. So definitely we are going to carry on to see if this model can work in the real world with students, and then we can modify it from there and expand it further. I hope this answers your question.
Yes, indeed, that answers my question. And I'm happy to see there's still a lot of work for you to do to follow also the other steps. And so I hope in the next years you will be presenting that work again. That's
I
really
hope,
interesting.
I hope so too.
So, if there is no other question, I would like to thank Pakis again for his presentation.
Thank you so much.
Thank you.
All right, bye-bye.
And I guess we can move on. So, the next speaker supposed to be Alfredo Cuzzocrea, who I believe is not online at the moment. So I think if Vladislav is okay with that, we could move on with his work.
Yes, could you hear me?
Yes.
Nice. Yes, I'm ready.
Okay, that's great. So the next work which will be presented is presented by Vladislav Kovalevsky, and the title is AutoML Framework for Labor Potential Modeling. So please, you can go on.
Yes, just a moment. How to switch on the presentation. Just a moment.
Yes, take your time, please.
I can't find how to share this. Yes, I see now.
It's the third button from the left. Okay.
Yeah.
You can also share the full screen view if you want.
Now, could you see my screen?
Yes, but not full screen. You might also use presentation mode if you prefer to see the presentation full screen.
Presentation mode? No, I turned full screen now. Oh.
No, now it's showing the slide, but I mean, it's still readable.
Oh, I try to. If I have a minute, I will find the right way.
Yes, take your time.
So I need to expand the window now.
Yeah, if you are sharing your screen, the full screen is just enough to
I
start the
see.
presentation.
I switched to full screen, but how it's look now?
So if you did not share the full screen, but just a window, it will not be visible. So you can just get back if you want, and then share the full screen, not just a window from the browser, I mean, from Jitsi.
Let's see.
So you can get back to Jitsi.
Yes, I get back to the Jitsi.
Okay, and now when sharing your screen,
Sharing screen, and all the screen show.
yeah, so the third option, the full screen.
Third option. This way.
Now try to share. Yes,
No.
now it's perfect.
So I shared the full screen and
Yes,
expand. Okay, now it's okay.
yes,
Okay, nice.
please go on. Thank you.
So I'm starting. Good morning once time again. My name is Vladislav Kovalevsky. I'm from St. Petersburg, from Federal Research Center of Russian Academy of Sciences, and my topic for today is automated machine learning framework for labor potential modeling. So first of all, the motivation. The field of human capital is a field that explores the dependencies between the properties of some individual, their abilities, knowledges, and the income and the profit that, of them and the society as a whole. And the human capital management can improve the workforce productivity and help HR managers to hire, engage, and retain employees when they know the capital, what they're capable for. And the estimation of such labor potential, therefore, is an important task and is crucial for human capital management. But unfortunately, there is no single approach and definition of what is how to measure the labor potential and how to deal with it. Because this is a poor formalized problem. So why it's a problem of labor potential estimation is complex? Because yes, this is complex analysis task of large data sets of digital profiles of workers. Each worker is defined by its digital profile, where written his different attributes and features, and this profile contains different types of data. These attributes can be divided into four groups: socio-demographic, moral, professional, and psychological. And into this group, there are different parameters, different attributes, and they have large variability of types and could be qualitative, quantitative, continuous, discrete. So very different types of parameters can describe the worker. So it's hard to use traditional methods to catch the dependencies between these parameters and the potential labor potential. So one way to overcome this limitation is to use the methods of machine learning when from some large examples data we can build come up with a model that captures this connection between input parameters and output parameters. For example, neural network models. So the task of labor potential estimation could be seen as a machine learning problem from different points of view. For example, it could be seen as classification problem when individual should be rated to some class of workers based on its parameters, or regression problem when the worker when the result is not some class but some numeric form of the potential, or clustering when we would like to see to which clusters the workers could be divided. So for nowadays there are many different machine learning algorithms were developed for different tasks, and now the task not only build a model but to but also to choose the right algorithm among the sea of different algorithms. So we get to the problem of automated machine learning. If we have different automated if we have a different machine learning algorithms, and each algorithm has its set of hyperparameters, the parameters that define its work. So the task that is often referred as cache problem, that stands for combined algorithm selection and hyperparameter optimization. The task is to say for some given data set, find the best algorithm and values of its hyperparameters that will build the best model for the given data. The best model, it's meant to minimize value of error when testing the model that was built from using these algorithms and hyperparameters. Hyperparameters that define the work of algorithm. For example, it could, if we speak about neural networks, the hyperparameters could be a number of layers and connection between them. That this is values that we define before learning step, because at the learning step we only change the weights, but the structure itself it's not changeable. So the hyperparameters it's the parameters that we define before the learning step. For now, also we go a step further, but not only there are many different algorithms to deal with machine learning problems, but also we now have many automated machine learning libraries, also libraries that deal with this problem of searching for the best algorithm and hyperparameters. At this table, at this slide, we can see a different automated machine learning libraries that exist now. They all follow the common schema that each auto machine learning solution has some underlying machine learning library, and search into this library among algorithms that include in this library to find the best algorithm. And they differ in the language that they use. If they cross-platform or oriented only to one operating system, some of them have graphical user interface and some lack this interface, only command line. And also some of them enable some limits on search, for example, limit time to search or memory, or enable parallel runs and so on, and another like these capabilities. And based on the comparison of these libraries, we choose some of them that share some common capabilities that could be easily united to use them in one framework. And so the framework was built that looks in this way. We have some data as input. This data is divided to each one of the modules of each one of the libraries, and each library requires its own data preprocessing to work then with the data. So preprocessing is made unique for each library. Then every library searches for the model to suggest what will be the model that work best with the data, with input data, and then we get the results from each library, the models that it should suggest, the metrics that it gives on the tests, and then we unite this one in the common output to see the common results, united results. So we have input data, and then it's divided to 3 or several parallel runs of different libraries. It will be more efficient that run the libraries separately and gives us not only the result of one library, but at the same time results from different libraries, and we can see them and compare. So now we return to our problem of labor potential estimation, and we would like to see how the developed framework can deal with this problem. So as every machine learning method, we need the data to fit our algorithm to get the model. So we need the data about workers and the labor potential to use, because this after all, this is supervised methods. So we need some right answers to learn our model. And for example, we can use the data sets that present open source, that present an open source repository, for example, on Kaggle. The Kaggle dataset, the Kaggle site contain different datasets. Here we enumerated 4 of them, and we choose one of them to use in our approach to see how it works. So we used the dataset employee performance analysis featuring dataset, and this dataset, as we can see, it includes 1,200 records about workers, and each worker, his profile defined by 28 features, different features. To be able to see them, I show here only first some features and the last one, performance rating. So we have age of worker, gender, status, how often he has travels from his work, what is educational level, and so on, so on. And the features we would like to predict its performance rating, how well the worker is performing. So in this picture, we could see that there is 3 types of performance: good, poor, and excellent. And we can see that good is most commonly rating, because a lot of workers they are good, and only some less part of them they are excellent or poor performing. So the task, as we could see, is classification task. So we need to classify the worker, how well he would be performing based on the in his features. We want to predict its performance. So now here you can see the results of the experiments. We fed the previously mentioned framework with the data and got these results. We run the framework was built in such a way that we can use common constraints, in this case, constraint of time. So we have run the tests with 4 different time limits: 5 minutes, 10, 15, half an hour, and hour. And we can see different results on different metrics that these solutions supply to us: accuracy, precision, recall, F-score, and AUC. To see better what is happening here, we can see the graph here. This is a build. It shows how the accuracy depends on running time among different algorithms. And here we can see the leader, the solution of H2O is best among all the solutions. Then the teapot solution gets the next step, and then hyperopscalon, and then autoscalon. So we can see from the framework which one of the solutions was the best. And also from this solution we could see that in some cases, for example, for hyperopscalon, it's heavily depends on running time. Initially, in the 10 or 5 minutes, it's get worse performance, worse accuracy, and then from adding time for it to run to find the solution, it gets like almost the second place. But then when we adding more time, 60 minutes, it also gets worse because maybe some outfitting of the search. So to conclude, in this work we developed AutoML framework that unite several commonly AutoML libraries based of the exploration how we choose the frame solutions that could be united together. And the framework provides several capabilities. It enables parallel run of libraries that include in it enables slot data from local file or from OpenML website that also contains many data sets, and each data the unique preprocessing step for each solution, and also we share the same split ratio for all the data sets, and we search in parallel for the solution, and then from the metrics we see the result. And after that, the framework that was developed was used to model the poorly formalized problem of labor potential estimation in different time limits. And we show the results, which the solution was the best, and what we get when we use AutoML approach to this problem. So that's all. Thank you for your attention. Questions?
Thank you very much, Vladislav, for your presentation. I find that the labor problem is really interesting, personally. So it's good to see research in our field, in computer science, also related to this field. So is there any question from the public? So if not, I have, say, two related questions. So the first one is, while you mentioned that the problem is still poorly analyzed and formalized, right? There is not much research yet on that. You mentioned few data sets. So do they all report the same data? Like, yes, the same attributes you showed.
You mean this data sets?
Yeah, so in the next slide, you show some attributes. Are they consistent? Like, do they contain similar attributes?
They all similar, but with some different aspects. Some have some attributes, some lack of them, but they pretty much the same.
Okay, thank you. And the second thing is, to your knowledge, do you know if such data is already utilized somehow by companies to select new personnel, or is it still done mostly in the old way, like without analyzing data automatically?
Yes, yes, I understand, but I am not sure what's going on in all companies. But I suppose that they are introducing such methods now, maybe first steps, but they are starting to introduce. But I lack this knowledge of how deeply these methods are used now in companies, because my solution is wasn't used yet in any company. But maybe others are now introducing also some same methods into their companies.
Okay, thank you. I'm sure that when your work will develop further on, it will be of interest also for companies.
Thank you. I hope so.
Okay.
Thank you.
Well, thank you. Thank you again for your speech. And if there is no other question, I would check if there is if Alfredo Cuzzocrea, so the next speaker, is connected.
Hello, yes, I am.
Okay. Perfect.
You hear me?
Yeah, we can hear you.
Okay, perfect.
Okay. So I can see you connected with another name. Is that?
Yes, I am subset of Professor Alfredo Cuzzocrea.
Okay. So it's you, Luigi, who is speaking.
Good.
Perfect. So the next paper in the session will be a machine learning methodology for optimal big data processing in advanced smart city environments.
Exactly. Can I start?
Of course, please proceed.
Yes, I start. Share. Yeah. Okay. You can see my presentation.
Yes, but not yet full screen.
Okay. Ora is now.
Not yet. To make it full screen, you can just share the whole screen, or start the presentation, then get back to Jitsi and share the full screen window.
Okay, now?
No?
Okay.
Not yet. So
can you repeat me, please?
Of course. So the fastest way will be to share your full screen.
My full screen. Okay. Entire screen.
Exactly.
Now?
Now you can make it full screen, and it's working.
Okay, perfect. Okay. I start so.
Yes.
Dear Professor, I'm Luigi Canadien from India Lab University of Calabria in Italy, and it's a really pleasure for me to present our work, a machine learning methodology for optimal big data processing in advanced smart city environments. This paper aims to determine the optimal placement of fast and slow electric vehicle charging station with urban parking lots. The study focuses on location in urban environments with uncertain demand conditions due to variable traffic flows. The paper introduced machine learning methodology for supporting optimal big data processing in smart city environments. The heuristics in our proposal have been evaluated and analyzed, demonstrating their effectiveness to solve the optimal charging station location problem for electric vehicles, whose main benefits consist in achieving good approximate solutions while keeping a suitable computational time. The model takes a map with buildings and parking lots as input. The destination for electric vehicles users is a specific building, and public parking lots are considered potential location for charger installation. Several assumptions define the model's characteristics. It assumes the driver visits two buildings during the day, and when visit these buildings, they park their vehicles in a parking lot near their destination building. The definition of proximity for parking lots is based on a distance parameter, which represents the maximum distance that a user is willing to walk. The electric vehicle users are divided into groups representing different traffic flows, and each group is characterized by the two buildings they visit. The arrival time at the first building, the time spent in each building, and the travel time from the first building to the second. These parameters are deterministic and null. Additionally, the model assumes that a single recharge is sufficient for each group to complete their entire path. Dwell time is divided into short, medium, and long durations, and drivers choose charging mode based on electric vehicle charge state and dwell time. Cost of installing and cost of single charger are known with certainty. A limited number of chargers can be installed due to budget restriction and physical energy limitation. The number of drivers is uncertain, and its variation generates multiple scenarios. Here we have charging behavior. The changing behavior of users is described based on their state of charge when arriving at the first building. The users are divided into three classes, and their charging behavior is determined by the ratio of users in each class. The charging state is classified into low, in the middle, and high, based on the remaining charge in the battery. Mark generation. The algorithm starts by designing a pseudo-random city environment, ensuring that the generated data is realistic and coherent. It takes various inputs such as the number of buildings and parking lots to be placed, the minimum distance between buildings, and the desired length of the side of the square map. To create this city environment, the algorithm follows a step-by-step process. Firstly, it creates a square matrix with dimensions specified by the input settings. This matrix serves as a physical representation of the city map, where each location is identified by its cell coordinates. The assumption is made that each cell represents a 10 meter for 10 meter area. Next, the algorithm proceeds to place each building individually, and the X and Y coordinates for each building are randomly selected. A radius value provided in the input settings. Similarly, parking lots are placed using a similar approach as built-in placement. They can be placed with the specified radius of a building. Overall, this algorithm guarantees that the buildings and parking lots are positioned in such a way that overcrowding is avoided, and the specified distance between them are respected. Here for group generation, we can say that to create a realistic flow of electric vehicle users, a larger number of groups need to be generated. Each group is defined by the following characteristics. Electric vehicle users visit the same first and second building. They spend the same amount of time in both the first and second building. They arrive at the first building at the same time. They take the same amount of time to travel from the first building to the second. To achieve this, the algorithm randomly selects different first and second buildings, arrival time slots, dwell times for both buildings, and travel times based on the distance between the buildings. The algorithm also ensures that two identical groups are not generated. The number of drivers in each group G is determined by scenario and is influenced by uncertainty. In each scenario, the number of drivers is assigned to each group using the following steps. A popularity index QB ranging from 0 to 1 is assigned to each building. The total population of each building is determined by considering the popularity index, as well as the mean and variance of the population of a single building. This is done by selecting a random value. The total population of each building is then allocated randomly to the groups that have access to that building. The value for a group is the sum of the random assignment from the first and second building. In order to properly define constraints and the objective function, we introduce two subsets. First subset contains the groups whose dwell time in the A on TH building is equal to that of J, and parking lot P is a possible parking lot when visiting that in building. The second subset contains the groups that use charging mode R and may occupy parking lot P in time slot T. And all the decision variables of the problem are reported in this table, name, description, and etc. All the variables. A heuristic model consists of a first stage and a second stage operating on the same data as the mathematical model. At the first stage, the models determine the placement of charging station, fast and slow chargers in parking lots. In the second stage, the models determine the number of electric vehicle users who recharge their vehicles using the installed chargers. The drivers are divided based on the type of charger used and dwell time in the building where they recharge their electric vehicles. The first stage of the heuristic model involved determining the parking lots that should be equipped with chargers and determine the number of fast and slow chargers for each parking lot. To determine the number of fast and slow chargers available, the fraction of drivers belonging to each class and the cost of purchasing and position the charger are taken into account. Using this information and computation is carried out to establish the optimal number of fast and slow chargers that can be installed. The next step is to assign the maximum number of chargers that can be installed in a parking lot M to the most popular parking lots on the map. The installation process starts with the positioning of fast chargers, followed by the positioning of slow chargers. The outputs of the first stage are two lists, one for slow chargers and the other for fast chargers. And each list provides information about the number of installed chargers for each equipped parking lot. The second stage of the heuristic model involved the consideration and adaptation of three main concepts. Are connection matrix, charging site degree, and electric vehicle degree. The connection matrix is a P per B matrix, and here in each element will be equal to 1 if building B can be reached from parking lot P, and 0 otherwise. This condition is satisfied when the Euclidean distance between the building and the parking lot is smaller than the maximum walking distance alpha. Note, okay? The charging site degree represents the total number of users who can park in the selected parking lot P. And lastly, the electric vehicle degree indicates the number of parking lots where group G can park. The input structure is modified to divide people into subgroups based on parameters such as visited building, arrival time slot, charging mode, dwell time, subgroup cardinality, subgroup class, and group ID number. And these subgroups are grouped based on the scenario and arrival time slot. The heuristic model places 5 fast chargers in parking lots with the 0, 1, 2, 3, 4, 5, and 8, and 5 slow chargers all in parking lot with ID 7. Comparing to this to the mathematical model results, the heuristic model identified the same parking lots needing chargers. However, instead of 5 slow chargers in parking lot with ID 1, the heuristic model placed 5 fast chargers. This preference for fast chargers is due to the algorithm structure prioritizing them. After multiple simulation, it was discovered that this preference is suitable for cases with many diverse electric vehicle users, reflecting a realistic scenario. Here, the stability of the heuristic model was tested in both in sample and out of sample scenarios. In sample stability was tested on 10 scenarios, 3 with 50 scenarios, while out of sample stability was tested on 10 scenario 3 with 200 scenarios. The stochastic heuristic model is considered so stable and consistent. And there are some fluctuations in sample stability, but they are still within an acceptable amount. Thank you all for your attention. Can I close? Stop sharing?
Thank you, Luigi. Sure, you can.
Thanks. Many thanks. Have a good day.
Oh, you too. Thank you again for your presentation. And is there any question? So I have a question on the data you used. So of course, such experiments are normally performed with synthetic data.
Exactly.
Because it's difficult to gather real data for such a big context, let's say. But since this is a really cutting edge topic, let's say, really of interest now, do you know if there is there is some research ongoing on gathering real data on that problem?
Yes, probably yes, because it's a topic, it's a modern topic for future arguments to present in the future.
Yeah.
So yes, are many researchers that do this research, and probably in bibliography that we use it. We saw these papers, and very much example of use real data for this.
That's great, because I can see it can be applied to really big campuses, for example, or even cities. So it will be for sure interesting to see how this develops in the future.
Yes.
Okay, so if there is no other question, thank you again, Luigi, for your presentation.
Thanks.
And we have one last presentation, which should be presented by Professor Kutsokrea again, and who is going to present it?
Good morning. I am Carmine Gallo.
Good morning, Carmine. So
for the presentation.
Perfect. So at 11, a new session starts. So
Okay.
we should end before that time, let's say. So the next work, which will be presented by Carmine Gallo, is structural node representation learning for detecting botnet nodes. So Carmine, you are free to start.
Okay. I share.
Okay.
Do you see?
Yes, it's not full screen yet. But if you want to present it like that, it's also okay. It's visible.
Okay. We present a method to detect botnets in the slides. The increase in devices that are always connected to the network was one of the main issues with botnet detection that we considered while developing this strategy. The exponential growth of IoT devices has increased the possibilities for cybercriminals to expand and grow botnets. Cyber attacks have become more common. Having many devices connected to the network facilitates attacks such as spam, DDoS attacks, the transmission of virus and malware, theft of password and credential, and even cryptocurrency mining. These are some of the top cyber attacks using botnets. Many effective botnet detection techniques use graph neural network CNN models to obtain models that describe how botnets behave. GNNs can acquire structural information, but the proximity of the nodes limits them. Using the concept of similarity, they can interact with machines that appear to be trustworthy but are actually botnets. As a result, we can argue that using the CNN model to identify a botnet might be inappropriate if it has been set to a different network than the one it will be evaluated. In the study, we provide a learning methodology of SERGN inferential graphing to achieve better results. By combining this strategy with a neural network classification models, botnet nodes can be identified even on very large network. As botnet continue to grow, it's safe to say that the SERGN inferential model is a more effective detection strategy than GN models. For our purpose, we use Mirai malware used against organizations such as Krebs on Security, web hosting service OVH in France, and even DNS provider Dyn. Figure illustrates the conceptual design of a Mirai-based bot that turns IoT devices into proxy servers. In the case of client-server botnets, if the CNC control node is located and isolated, the entire botnet can be found and subset sequences stopped. In P2P type botnets, which are capable of sharing CSC commands when discovered and have little knowledge of the other botnets, making detection even more difficult. Even conventional methods such as DNS blacklist and domain names require a deeper understanding of networking and botnets. As a result, this type of strategy only works if the data is available and hasn't been changed by the botnet. Many representative learning methodologies have been widely used. For example, the deep work method, which uses NLP, neuro-linguistic programming, and is based on the word-to-vec algorithm for the skipgram model. Try to predict words in context starting from a central word to optimize all nearby nodes. Also, by moving from word sequence to graph, DeepWalk extended the skipgram models to establish this transformation and provide data on localized network topologies. It used a randomized path traversal mechanism. DeepWalk procedure for each node perform n random passes starting at the node. 2. Treat each walk as sequence at node its strings. 3. Train a word-to-vec model using the skipgram algorithm on the string sequence obtained previously. Each of these techniques is good of capturing connectivity data between nodes, but they fall short when it comes to maintaining critical network architecture characteristics for both machine detection. Only neural network and the iterative inferential method SERGN are able to produce inference that offer prediction on graph completely different from those used for training. The primary goal of our botnet detection method is to gain an understanding of the structural representation of inference algorithm. The P2P model is used in the experimental to show how graph representation learning can find anomalies that are more difficult to find with other techniques. Real background traffic data obtained in 2018 related to IP on a backbone monitored by Qaeda was used. In this investigation, we constructed controller network used the Bruin Academy lat-short and late-short P2P topologies. Furthermore, to detect botnet attacks in the communication flow, we also use a real P2P network. The frequency, number of nodes, decrease, and the degree, number of edges of the node increases. This pattern suggests that most nodes have degree under 2 and that there are many those that are well related. Each network has 960 P2P graphs with an average 144,000 nodes, over 1.5 million edges and 10,000 botnet nodes within each synthetic graph. 10,000 botnet nodes were used in the datasets used for training. 10,000, 1,100 botnet nodes were used in the test dataset. Since less than 10% of network nodes are part of botnets, all of these networks are seriously imbalanced. The figure shows the value for the main node structure in the various datasets. The proposed approach is based on inferential SERGN, which is an iterative process of learning structural representation with inference capabilities. The symbols we use in your explanation are NC, the number of clusters chosen for node representation, and NGC, the number of clusters chosen for graph representation, K, the depth of exploration equal to a node's key-op neighborhood. Using this methodology, the representation of a node is updated iteratively. Each iteration size of a node representation is determined by a user-selected hyperparameter NC. The actual node description is grouped into NC k-means cluster to provide the node description. A node's neighborhood are then aggregated into its structural description when it has been updated by adding the probability of neighborhood nodes that are part of each cluster for that cluster. Each iteration represents a deeper level of study, and after key iteration, a description of the node will include information about its key-op neighborhood structure. Using the 8DGN model, which is a GNN specifically designed to identify botnets, we'll explore the contrast. We will use the following comparison to demonstrate how inferential SERGN is useful for generalizing invisible data. The figure shows the result of the NN classifier and compares the representation of the inferential node SERGN and ABDGN. We can see that SERGN1 behaves much like an ABDGN for all datasets, even though the model was trained to represent node using randomly generated graphs and specifically trained on 50 graphs from one dataset. This contrasts with the ABDGN neural network model, which was trained on 80%, 768 of the dataset graphs. When evaluated on all other synthetic datasets, SERGN1 and ABDGN behave the same when trained on the Kadam topology, similar to training on late and short data. The F1 score for ABDGN drops below 10% with no change in performance on the other synthetic datasets. Interestingly, when Debru data is used to train each model, ABDGN perform poorly in classification in all other topology, as well as failing to accurately detect boats in the real-world dataset, while SERGN1 perform well in this situation. When SERGN1 and ABDGN are trained on real-world dataset, they behave similarly on test data produced from the same dataset. However, ABDGN shows significantly lower performance in classification tests in the first-tail topology. This result demonstrates that the use of neural network classifier and inferential SERGN to represent nodes also outperforms even the specific botnet detection method on hidden data, despite having been trained on a much smaller dataset. Furthermore, the results show that ABDGN model can only recognize bot in real-world data after gaining preliminary insight into the structure of the specific botnet. We can observe that even on real-world test data, it is significantly effective to train a neural network classifier for non-structured representation using only one graph from a synthetic dataset. A neural network classifier with inferential search gen allows identification of botnet, regardless of the topology used for training, which is a significant advantage over model based on prior knowledge of the graph topology. Using inferential search gen in tandem with a neural network classifier will result in very high botnet detection capability. Due to the difficulty of adaptability, CNN technique may not be able to identify previously unknown botnet topologies. Thanks for the attention.
Thank you, Carmine, for the interesting presentation. Is there any question from the public? So if not, I have one question. First, I found really interesting the capability of your method to generalize and to adapt to new domains. It's really interesting to see that the method can be trained on one topology and then used efficiently on other topologies. So
Yes.
that's really interesting. One thing I would like to ask you is, you mentioned that after several iterations, the method is able to learn the topology of a network up to a certain k value. So at a distance k from a node, let's say. Did you do any experiment to see which is the optimal k value to have a trade-off between, let's say, training times and efficiency of the method?
In the experiment, I have provided for 50k value.
Okay. So at 50 distance 50 from one node.
Yes, yes.
Well, that's much, because yeah, it's a really high value. Interesting.
Yes.
Because I mean, from my knowledge in other domains, so not in botnet detection, even low values, so like 2, 3, at maximum 4 are sufficient to obtain good results. But
yes, but the extension of botnet, I test the method on a very extensive botnet.
Yeah, that's true. And also the mean degree of a node is really low, right?
Yeah.
So it's, yeah, for sure it's useful to go further, let's say. So thank you again, Carmine.
Ciao, Giulio.
I stopped the share.
Yeah, you can stop sharing. Thank you. If there is no other question.
Okay.
And so we now conclude the first session, and we will have a 5 minutes break, I guess, before starting the new session. I would like to thank again all the speakers for their contribution. And so we're bound to start in a few minutes again. Thank you.
Ciao, Giulio. You can listen in?
Hi, Gustavo. Yes, I can hear you. And I can see you as well.
We can make a little test if I can see my presentation.
Of course.
Thank you. No, 1 minute, please. No. You can see Julio?
I can see it, but try to make it full screen.
No, 1 minute, because I have this part here.
Okay.
I see the video.
Yeah, I see it's full
Okay.
screen, so it's perfect.
Thank you.
You're welcome. So see you in a few minutes.
I wonder, I thinking that is the last presented today.
Mhm.
Don't worry, Lucas. Here in Chile is the 4 of the morning.
You're far.
Wow.
I got up in a little while.
Yeah, in the next room we have my little girl is sleeping, so for this reason cannot speak very high.
Yeah.
Don't worry, we can hear you clearly anyway.
Okay. For me it's better parlare italiano. È più facile.
Purtroppo non possiamo.
No, non possiamo adesso. Però Giulio, questo cognome, questo nome è della Sardegna, no?
No, è un nome italiano.
Italiano, non è proprio di Sardegna, no?
No, è un nome che viene dal latino, come Giulio Cesare.
Ah, va bene.
È diffuso in tutta Italia.
Es que Pireddu es de la Sardegna. Pireddu.
Sì.
Sardo. Por questo io pensava che...
Okay. I think we should start, not to have delays, and also for you to go back to your sleep then later. So let's start with this new session of the general track. Wait. Okay. So I will kindly ask the presenters to turn on their camera during their presentation. And so now the first presenter will be Lucas Barbosa Rocha. Hi, Lucas. Presenting the paper Heuristics for the De Bruijn graph sequence mapping problem. So, Lucas, you are free to start your presentation.
Can I start?
Yes, of course.
1 minute. Okay, I will start.
Yes, please.
Can you see my presentation?
Yes.
Is okay? My sound is okay? Okay.
Yeah, we can see it.
Okay. Hello, guys. My name is Lucas Barbosa Rocha, and I will be presenting my work, Heuristic for the De Bruijn graph sequence mapping problem. Okay. This is a brief summary of my presentation, divided by introduction, my problem, the approach, tests, conclusion, and reference. Okay. To begin, I will provide some important definitions, giving an alphabet called sigma, and a sequence is constructed using this alphabet. For example, ACGAT is a sequence constructed by alphabet sigma with ACGT. A substring refers a part of the string, such as CGA is a substring of my sequence ACGAT. A camera is a substring of length k. A prefix this is a substring that includes the beginning of sequence. For example, A, AC, ACG, ACGA. Not all sequence. And the suffix is a substring includes on the end of the string. For example, T, AT, GAT, and CGAT. Okay. A reference sequence, for example, give you a set of sequence. A reference sequence is the one that most accurately represents the set. For example, the first sequence here represents the first set, and the second here represents the second set. So one sequence represents all the set. But the reference sequence, this is biased because the sequence reference represents a limited set. So one approach to address this problem, this bias, is utilizing a more robust structure to represent the sequence. For example, a sequence graph. So we have a lot of reference sequence. For example, this is two sequence, and I will use a sequence graph to represent all reference sequence. Okay, so a graph consists A graph consists of two sets, and nodes and arcs. In a graph, we can traverse two arcs using paths and arcs through the nodes. During a walk, we are allowed to revisit the nodes. For example, we can this walk V1, V5, V8, and V1. So this is a walking because I repeat the nodes. But I have this F, V1, V2, V3, and we isn't repeat the node, so this is a path. Walk, I repeat node, path, I don't repeat nodes. Okay. A sequence graph is a graph where the nodes are labeled with sequence. In my work, we have two sequence graphs, simple sequence graphs and gibbering graphs. Simple sequence graphs with node is labeled with one character. And all walk in this graph induce a sequence, spell a sequence. For example, this walk or path V1, V2, V3, and V4 induce a sequence A, T, C, G. For example, I this path V1, V2, V3, V5, V4, which character in their nodes is using by spelled the sequence P, sequence S. In a gibbering graph, with node is labeled with a um, sequence of length k, and there exists only one arc between two nodes, for example, V1 and V2, with the suffix of U of length k minus 1 is equal to the prefix of V of length k minus 1. For example, this suffix is equals this prefix. So there are arc between two nodes. And here, all our path induce a sequence, but follows this rule. Include the sequence of length k, the first node, and the last character, the another nodes. For example, this path V1, V2. I will use the camera TTC, and I use the last character by induced sequence. So the induced sequence by P is TTCT. Okay. In my last definition, the edit distance refers to the minimum number of operations to transform one sequence in another sequence. These operations are insert, remove, and substitution. For example, I have the sequence S and the sequence T. I can remove the first character. I can change the 5 character for A. I change the 6 character G to C, and I put or insert in the end the character T. So I use 4 operations to transform S into T. And my edit distance between S and T is 4. Okay. But based on these definitions, the problem addressed in this work involves a gibbering graph and a sequence S. I have a gibbering graph and a sequence S. The objective is to find a walk P in the gibbering graph so that the induced sequence from the walk P and S has the minimal distance. For example, I have this walk or this path induced this sequence. And I have another walk and this another one induce this sequence. So my answer, the answers for my problem is U, because the edit distance between S and the induced sequence by two paths is U. So I will find the path or the alk, the induce the sequence and the sequence, the edit distance between the induced sequence and my sequence S is minimal. So here is the input, my problem, a sequence S integer graph. The goal is to find out P whose edit distance between S and sequence paired by P is minimal. This problem in the literature has three variants: change on the sequence, change on the graph, and change both the graph and syncing all in the same time. In my problem, we study the change on the sequence. Our work help is to close the gap for sequence graph brain that was open in the literature. This the same problem was studied in another graphs, in general graphs, in simple sequence graphs, for example. But for Gibran graphs, the problem is was open for changing sequence, and for changing in the graph is very I I say is very famous in the moment. Little papers are studying this problem. So for our approach, I will mention a problem that was being problems studied in the literature for simple sequencing graphs by Aetros, Houghton, and Marshall. Houghton and Marshall developed two algorithms for simple sequence graphing. The first algorithm, GSMP algorithms, that return the mapping. So that return the walk in the graph that induce this sequence. So these algorithms returns the mapping, the walking, in other words. And the authors developed another more efficient version of GSMP, but this new version, GSMP-G algorithm, returns the mapping distance. So this is another algorithm developed for this example, the number 1, on the coast to the mapping this sequence in the graph. Okay. For initial approach, we need adapted these algorithms, GSMP and GSMP-G algorithm. For this adaptation, we need to convert the Gibran graph in a simple sequence graphing. In our paper, we prove this equivalent, and then apply the two algorithms, this or this. The conversions process involves dividing or splitting with node in k-nodes and establishing the necessary connections to ensure the graph still induces the same sequence. So we split the first node in k-nodes, the second nodes in another k-nodes, and establish the necessary connections. For example, arc between A and C, between C and G, between C and G, between G and T for two chimeras, and connect the G with T and V3 and V6. So these two graphs induces the same sequences. We have made this adaptation and implement it in two algorithms, named GBrain Map 2, BMT, and GBrain Map 2G, BMTG. However, despite the functionality of these implementations, they are not efficient for real-world scenarios. For example, BMT consumes a significant memory due to the construction of large auxiliary graphs by the GSMP algorithm. On the other hand, BMTG is capable of running several examples, but suffer from a long execution time because the GSMPG algorithm, while consuming less memory, takes a considerable amount of time to execute. Therefore, we have focused on developing heuristics to address these limitations. The first heuristic for our problem we follows two steps. The first step is to find anchors. Anchors are chimeras are present in sequence S and the GBrain graph. It's important to note that there will be gaps since not all chimeras of S are present in the graph. The objective is my heuristics is utilize BMT or BMTG to fill these gaps. So I will use BMTG to find a path walk the first between first and second anchors, and I will run the BMTG for all anchors, or I use BMTG to find a distance to map, a distance to map, a distance, and I will find a distance this mapping using BMTG heuristic. So the first heuristic to return a mapping and return a custom mapping, a distance mapping. Okay. We implement these heuristics. We call here BMT-A1 and BMTG-A1D. Additionally, we have incorporated improvements using a Bifrost tool. Bifrost tool is a tool that constructs efficiently a GBrain graph. This tool employs its own interpretation of chimeras, resulting in an increasing number of anchors in the graph. As a result, the heuristic is more effective in accurately mapping the sequence into the GBrain graph. We have explored alternative approaches to heuristics using seeding and extending. In summary, seeding extending involve find chimeras in the graph and extend for AUK component character by character with sequence and walk in the graph. Idea of my second heuristic is I extend them by comparing each character of the AUK with the corresponding character in the sequence until the next CG is reached. Durante this traverse, we modify the last character of each CG to all possible options and continue extending until the difference is encountered. The longest walk of time is returned, and the camera from the end of the walk is further extended by modifying its last character. This process continues iteratively, taking the longest walk at each step until a significant portion of the sequence is covered. We introduce the improvements, the one of heuristics, and using a particular scenario. If no walks are found when extended through of possibilities, we remove the -1 length suffix from the seed and attempt extension again. My last two heuristics are BMTGA2, BMTGA3. Is a resuming our implementations, and here a testing. Sorry.
Lucas,
Okay.
sorry to interrupt you. You should conclude in 5 minutes if you can, please.
Okay.
Thank you.
Thank you. Okay. Sorry. Comparing the implementation, especially for BMTG return only distance, the proposed heuristics observe that the heuristics on average provide a double the response compared the BMTG. However, in terms of time execution, BMTG, BMTG-AT are heuristics are efficiently. So the time is the very fast in ratio in comparison with BMTG. In the graph, we present a number of chimeras in the graph between these numbers. Sorry, I'm nervous. Regarding the heuristics that return the mapping, there is a significant consideration. BMT consumes a substantial amount of memory, which prevents extended tests for comparison. To assess the effectiveness of the heuristics, we utilize the BMTG version that only returns the mapping distance by comparing the calculated edit distance between the sequence returned by heuristics and the input sequence with the distance obtained from BMTG. We can evaluate the performance of the heuristics. The advantage here is that the implemented BMT version has limited feasibility, while the heuristics provide opportunities for executions. In these new tests, the heuristics demonstrate an average mapping distance that is twice the distance compared to BMTG. BMTG is twice. The version implemented the Bifrost tool benefits from its unique interpretation of chimeras in the Gibran graph, resulting in improvement in mapping compared to our implementation. In terms of execution time between two heuristics, is capable because the BMT is incapable of executing. The main advantage our heuristic is that now is possible to map in a sequence in a Gibran graph. Science in BMT isn't agree this tasking. All heuristics between using BMT and CG extend, it becomes evident that utilize in this new test the heuristics, we can see using BMT A1, BMT B using the Marshall and Harting algorithm is the best in comparison to CG extend, but CG extend is interesting results. So in question of the time, using Marshall algorithms with Bifrost is the best heuristic. In conclusion, we have implemented two novel adaptations to close the gap for changing in sequence. We propose heuristics, improvements in our heuristics, and this heuristic is to take the memory and time constriction associated with these implementations. The perspectives we consider explore parallelism, improvements reducing memory in Harshal and Marshall algorithms, new heuristics involving extend, and the Bifrost tool, and the approach to the graph change version of the problem. Is my reference, that is all. Sorry. I finished.
Thank you very much, Lucas, for your presentation. Is there any question from the public?
Mhm. Okay.
So, if there is no question from the public, I would like to ask one because it's not my field. I mean, these areas of research. So I would like to ask you for which applications are these kind of graphs used. Um, I would suppose something related to uh, genetics, for example, but I'm not sure. So I'm asking you.
Sorry, I can't understand the question.
So, I mean, such kind of graphs, the Bruin graphs,
Mm-hmm.
what are they used for? What do they model, for example?
Applications you're
Yeah,
using?
exactly.
Okay. Is the first application we can find here is to correct the short sequence and the short reads and long reads. The short reads is more accurately, is more correct, and the that graph is built using only short reads, and the long reads is the minus correct in relation to short reads. So I use this application for correct the long read.
Okay.
Is the correct the long read?
Okay.
Is the first application.
Okay. Thank you.
Thank you.
So, if there is no other question, I would like to thank again Lucas for his speech.
Thank you.
And we can move to the next speaker. Is Mikhail Litayev online? Okay, no, it seems like Mikhail is not online. So we can move to the next paper, and maybe if he connects later, he can present. So is there anyone for the invariant polarization signatures paper?
Hello, I'll present this paper.
Okay. Hi, Edward. So,
Let me
Lucas,
share my
you can
screen.
stop sharing.
Okay.
Okay, so Edward Turner will present the paper Invariant polarization signatures for recognition of hydrometeors by airborne weather radars. Please, Edward, you're free to go.
So, hello to all. I am Edward Sopner. I am from National Aerospace University, Kharkiv Aviation Institute, Ukraine. And the topic of my report is invariant polarization signatures for recognition of hydrometeor by airborne weather radars. Hydrometeors such as thunderclouds, hail, and snow pose a threat to the safety of civil aviation flights. And thunderclouds are dangerous because of the possible damage to the aircraft by lightning. Hail and snow create a threat of aircraft icing. And due to their bad weather conditions, a large number of accidents and disasters occur. And to obtain information about weather conditions, weather radars are widely used. Now it's one of the most effective equipment for the operational observation of clouds, thunderstorms, and to measuring their characteristics. Ground-based radars are installed at all large airports and ensure flight safety in the airport area. And airborne weather radars are installed in the aircraft radar, which allows the pilot to know the weather condition along their flight path. And to recognize the dangerous hydrometeors, weather radars with dual polarization transmitter and two-channel receiver are widely used. And the physical basis of such polarimetric radars function in hydrometeorology is the dependence of signals reflected by the heterometeorous particles on their size, on their shape, or some other characteristics such as angle, etc. And a complex polarization backscattering matrix, a size of 2 by 2, gives a complete information about the polarization properties of objects, and it relates the intensity of the emitted and the reflected from the object signals. Complex polarization backscattering matrix describes the reflecting properties of an object at orthogonal polarizations at a given sensing frequency. However, its values depend on the orientation angle of the reflected object. In addition, the radar observes a huge number of independent droplets in the impulse volume. And in this case, each this object contribute its own polarization shift into the reflected signal, and we observe the sum of these shifts. Therefore, in radar metrology, a number of integral radar signatures are used. It's the radar reflectivity or the radar specific cross-section for the horizontal and vertical polarizations, the differential reflectivity, and linear depolarization ratios are also used. Usually, these characteristics and a number of others are used to recognize various hydrometers. However, the polarization backscattering matrix can be reduced to the diagonal form. And based on this, Anatoly Popov proposed the decomposition of the matrix into an independent set of operators for transforming the amplitude, phase, and polarization of the reflected signal. The parameters of this decomposition are called polarization transfer functions, and they can also be used to recognize different types of hydrometers. And an algorithm for calculating these parameters based on polarization backscattering matrix was also proposed. Next, we made experimental studies of the traditional radar characteristics of hydrometers and the proposed invariant polarization signatures. And to do this, we used an X-band radar polarimeter, which are shown on this slide. And on this slide, you can see an example of hydrometer radar cross-section obtained using the radar. And based on the obtained data, histograms of the elements of polarization backscattering matrix were constructed. But more interesting were the obtained traditional polarization characteristics of hydrometer. As we can see, it's really difficult to recognize the type of hydrometers by reflectivity at different polarization at close values of their intensity and water content. And the distribution of this value for different hydrometers may be too close and overlap each other. And the polarization properties of reflected signals can be more clearly considered using the polarization diagram, on which all possible polarization states of an electromagnetic waves can be shown. As an example, in right side, a two-dimensional histogram of the polarization of signals reflected by the rain and hail is shown. We can see that the polarization of the reflected signal changes in general randomly, but it concentrated in some certain areas of the parametric diagram. And next, we considered proposed polarization transfer function. Analysis of the histogram of the polarization ion basis parameters shows that depending on the hydrometer type, the position of the distribution mode for the object ion polarization shifts. And for the thunderclouds, the mode of the ion polarization is located near the orientation angle of 100 degrees. For the rain of the medium intensity, it's about 110 degrees. Then for the solid phase hydrometers, it noticeably shifts towards larger angles. For hail, it's approximately 130 degrees, and for dry snow, it's almost 145 degrees. And with a relatively small dispersion of eigenpolarization shifts, this object becomes distinguishable. And the obtained result is quite understandable from the point of view of the microphysics of hydrometers. There is a belief that in thunderclouds, the water droplets are more flattened and more ordinally orientated due to the presence of electrostatic electricity, which leads to a more pronounced mean orientation of the observed average droplet. Instead of hail particles, hail much less orientation order, while snowflakes and ice crystals are oriented chaotically. So the eigenpolarization signatures can be used as an indicator of the degree of particle ordinate in such different hydrometers. And the polarization transformation parameters of the electricity and the orientation turned out to be interesting for practical use. They are sensitive to the charge's electrophysical properties, dielectric permittivity and conductivity. These transformation parameters strictly distinguish the phase state of the hydrometer and group them into this object with classes such as liquid water and solid state water. It can be snow or ice. However, the histogram of the thunderclouds almost completely coincide with the rain. And hail objects has a pronounced bimodal nature. Part of samples refer to the hydrometer in the liquid state, and it's almost identical to the rain in its position in the polarimetric diagram. And the second mode is shifted noticeably close to the area occupied by snow. This is due to our measurement technique. We scanned in general a wide range of haze. And in this case, we can see like a solid state hail in the clouds and also the hail that began to melt. And thus, the polarization transformation parameters of the ellipticity and orientation can be used as an indicator of the hydrometer phase state. And in this work, we studied the informativity of hydrometers invariant polarization signatures, which were derived on the basis of coherent decomposition of the polarization backscattering matrix. This allows us to identify new signatures that provide additional information about hydrometers. And on the basis of our own experimental data, we have shown that proposed polarization signature make it possible to get the hydrometer particles degree of order, which is a characteristic feature of the thunderstorm cores in clouds and the phase state of the hydrometer, and the presence of ice particles in it, hail particles, and other. No doubt, the obtained results are preliminary and required some frequent large-scale experimental studies, but the already available data suggests that expansion of the signature space will increase the reliability of detecting hydrometers, dangers for flights, and accordingly will enhance the safety of civil aviation flights. Thank you for your attention.
Thank you, Edward, for your presentation. Would you please turn on the camera? Oh, thank you.
Yeah.
I can see you now. So thank you. That's really interesting. although it's out of my knowledge field, but that's really interesting. And I wonder if there is any question from the public. Or if not, I will just ask something that I do not know if it will make sense, but from my point of view, seeing such charts makes me wonder if some kind of artificial intelligence methods can be used or can be at least tested to help better discriminating the different particles, or if they can be of any use, how much data you collected, if it is sufficient for such applications.
Thanks for your question. Yeah, we have a plan to use some artificial intelligence algorithms to recognize different solid states or different hydrometers. But now we don't have enough amount of data for this, because due to the situation in our country, we can provide experiments in this frequency band. And now we change our research direction.
Yeah, I'm sorry, but I do hope you will be able to gather more data, because I think it's also difficult to gather data, like even in let's say better situations. It's really expensive to gather such data, right?
In general, we worked with coordination with our airport, and we get some prior data from airport weather service.
Okay.
To compare our obtained data and with the real state of.
Okay, so I do hope you will be able to proceed further as soon as possible.
Thanks, Edward.
Thank you. Thank you, Edward. So if there is no other question, we thank again Edward for his speech, and we can move to the next speaker.
Thanks.
So is Mikhail Litayev online, perhaps, or someone for him? No. So we can proceed. I can see that Eloy is online, perhaps. Eloy Araujo.
Yes, I'm here. I'm trying to turn on the microphone.
Oh, we can hear you now.
Yes.
Still, we cannot see you.
Maybe now I'm here. Wait.
Oh, great. Yes, now we can see you. So the next paper will be extended pairwise sequence alignment, presented by Eloy Araujo. I will kindly ask you to keep your camera open while presenting, and also Gustavo, if you please can turn off the camera. Thank you. Just like I will do.
Turn off the camera?
No. You can
okay.
open.
Okay, wait a minute. Wait. Okay. Wait, can you see my presentation? Oh, it's not good.
Well, we can see it.
Okay. It's not presenting as I want, but wait. Okay. It's too small, huh? Okay, wait a minute. I think it's better. Okay. Wait.
Yeah, now it's much better.
I don't know what I do, but
Now
it's
it's
better.
working.
Okay, let's work.
Okay, so please go on,
is-
Eloy.
Okay, hello everyone. Good morning, good afternoon, or evening, depends on where or when you are. My name is Eloy, and this is the paper Extended Pairwise Sequence Alignment. I work by research at the Universidade Federal do Mato Grosso do Sul. I am in São Paulo, Brazil. It's almost 6 o'clock here. 12 graus Celsius, very cold for us. It's a great pleasure to be here again at ICCSA, and I hope you enjoy the presentation. Here is the summary of what we'll do. We have divided this presentation into 5 parts. Introduction, then we talk what this problem study is about, talk about the algorithm on the complexity results, and we end this presentation without conclusions. Sequence comparison is a useful tool for solving problems in many areas of computer science, such as text processing, computation biology, and pattern recognition. We use a scoring function to establish how similar or different two sequences are. And one way to do this is to define a score for each edit operations in a sequence of edit operations capable to transform a given sequence into another. Usually, the edit operation considered are operations of inserting, removing, or replacing symbols. The edit distance between two sequences is the sequence of edit operations whose sum of weighted edit operations is minimal, and it can be used as a scoring function between sequences. A structure that helps us visualize how similar or different two sequences are in modules based on editing operations that transform one sequence into another is an alignment. We insert space in the two sequences in such a way they are the same length, and we put one above the other. Each column represents an edit operation. The space symbol is used to represent the insertion, the deletion of symbols. To score the alignment, you use the scoring matrix, which is used to score each pair of symbols. The alignment score is a sum of the scores of the edit operations represented by the columns of the alignment. In this model, an optimal alignment between two sequences is an alignment whose score is minimal. OptA is the alignment score of the optimal alignment. Then the minimal alignment score problem is to find an optimal alignment between two sequences. Using dynamic programming, these problems can be solved in O n to power time, and there is no subquadratic algorithm unless theft is false. Now is not our problem. But not every set of edit operations that transform one sequence into another can be represented by a conventional alignment. In this example, a sequence of edit operations that transform sequence A into sequence B does not consider intermediate operations. In this model, a symbol can be edited only once, and therefore there are only three possible alignments: replace A with B, or remove A and then insert B, or insert B and then remove A. There is no alignment that, for example, replace A with C and then replace the C with B. An alternative is to represent the sequence of edit operations by an extended alignment described in 2023. And why study extended alignment? In this work, we are only interested in the theoretical aspects of the problem. In particular, algorithms and complexity. We have not investigated real applications. However, some events can indicate real applications. Back mutations, for example, when the two forms edit A to B and then B to A are shown to be adaptive. Adaptive mutations can occur in organisms that are under constant evolutionary pressure, and intermediate mutations occur. But we don't study these applications. So, in this slide, we present a formal definition of standard alignment of two sequences, say S and T. I won't go into too much detail on this definition, but an important observation is that this type of alignment is formed by columns, and that the first element of each column, when concatenated, form the sequence S if we remove all the space. And likewise, the last elements of each column, of the columns, when they are concatenated, they represent the sequence T if we remove the space. And given a score matrix, the score of a column of an extended alignment is the sum of the edit operations represented by the column. In the score of the extended alignment is the sum of the column scores. OptA, in this case, is the score of extended alignment with minimal score, and the optimal extended alignment of ST is that alignment whose score is OptA-ST. We also establish a notation that represents a minimal walk from A to B. We say alignment instead of classical or extended alignment if it's obvious. We note that a conventional alignment is also an extended alignment and has the same value when the scoring matrix is the same. This means that the extended optimal alignment score is always less than or equal the conventional optimal alignment score. A score matrix can be seen as a D-graph, where the vertex set is a set of symbols of the alphabet include the spaces, and each edge connects a symbol A to the symbol B is the editing operation score from A to B. And important information used in this problem and obtained from this structure is the shortest path between vertices. Floyd-Warshall algorithm describe an algorithms for finding the shortest path between all pairs of vertex in a weighted graph. The algorithm spends theta the n to the 3 power time. Well, let's go to the algorithm. On these slides, we are going to give you an idea of how to find an optimal standard alignment of ST when using the scoring matrix gamma. This algorithm is too easy and has 3 steps. In the first step, we obtain a second scoring matrix delta, such that the conventional optimal alignment score using the matrix delta is equal to the extended optimal alignment score using the matrix gamma. Then, using the matrix delta, we find the conventional optimal alignment A of ST. This alignment is then used to find an optimal extended alignment using the matrix gamma. Okay. In step 1, we will compute the matrix delta. Each entry of the matrix delta in row A, column B, corresponds to the score of the shortest path from A to B in the matrix gamma, or more precisely, in the graph D that represents the matrix gamma. This round store the minimal store walk. After obtaining the scoring matrix delta, the Needleman-Wunsch sequence alignment algorithms in all the n to the 2 power steps can be used to compute an optimal conventional alignment between S and T regarding matrix delta. This alignment is also an optimal extended alignment using the matrix delta with the same score. After obtaining the optimal standard alignment with this matrix delta, we can now obtain an extended alignment with the matrix gamma by recovering the walks, the optimal walks in the graph that we present in step 1. Let's now see a slightly more detailed example. Suppose this is a scoring matrix gamma using the Floyd-Warshall algorithm. We obtain this matrix delta and also obtain all the minimal walks between each pair of symbols in the graph T. Now, from the ST sequence and the scoring matrix delta using the Needleman-Wunsch algorithms, you can obtain the conventional optimal alignment A. Regarding the matrix gamma, this alignment is a conventional optimal alignment, but it's also an extended optimal alignment. To get extended alignment to gamma, we replace each column of the conventional optimal alignment or extended optimal alignment with another matrix. We replace by a walk between the symbols with the shortest path. In the analysis of our algorithms, we consider that the alphabet is constant, and therefore the number of elements of the alphabet is also constant, which implies that the number of elements of the alphabet squared or cubed, although the could be large, it's also constant. So in next one, we computed the matrix delta and spent alphabet qubits to get the matrix D, and therefore spent theta 1. In step 2, the Needleman-Wunsch algorithm computes the algorithm from the matrix delta, and this is done in quadratic time. In step 3, the replacement of each column of A by the corresponding walk takes quadratic time in the size of the alphabet and linear in the length of the sequence. And again, because sigma does not belong to the input, we have the total time spent in these steps is linear, and you can enunciate the following theorem to find the optimal standard alignment of S. The ST spent quadratic time on N, where N is the number of symbols of S plus the number of symbols of T. If the matrix gamma is a metric, then the optimal conventional alignment can be found from an optimal extended alignment in linear time. Bacchus and index result implies that if the algorithm finds an optimal extended alignment A in quadratic time, then use the above lemma. A could also be used to find an optimal conventional alignment of ST in subquadratic time, and therefore the Seth, that is strong exponential time hypothesis, is false. So there is no subquadratic algorithm to find an extended alignment of ST unless Seth is false. We present a very straightforward and efficient algorithm to find an optimal extended alignment, and we show that the algorithm is optimal unless Seth is false. It would be nice if we found a practical application where extended alignment were useful. This is the reference, and that's all, guys. Thank you very much. If you have any questions.
So thank you very much, Eloy, for the interesting presentation. Is there any question from the public? So,
sorry, I turn off my camera. I don't realize this
No problem.
Okay.
No problem. So
That's why I got the presentation better. Okay.
no, so I have a question for you. Just in the conclusions, you stated that you have to find an application for the extended alignment, right? So, is there any problem impeding impeding the application of it on the problems you showed in the first slide? Because I think that you mentioned some problems in one of the first slides, right? Where the
Yes, yes.
is useful. So, is there anything that doesn't allow you to apply to that problems?
Yeah, look, this is the first steps of these problems, but I believe that adaptive mutations could be the next the problem where we can try to see if this model can be used.
Okay, thank you.
Okay, thank you.
Is there any other question?
No.
So, if not, thank you again, Eloy, for your presentation.
Thank you very much, guys. Good work.
And so now we can move on to the next speaker.
Okay.
I will ask again, is Mikhail Litayev online or anybody else to present the work computational grid optimization? I guess not. So it's time for Gustavo Gatica. Thank you for waiting so long, even though it's night time for you.
Don't worry. This only I need to remember what making my PhD or not. In this time, don't sleep.
Yeah. So
now don't sleep for the children.
Yeah, just try not to
Now
wake up.
you can see my presentation.
I can see. So the next work will be a constructive algorithm for the split delivery vehicle routing problem. So please, Gustavo, you can go on.
And one moment for put the time, the chronometer. Now.
Okay.
Good afternoon, Greeks. Good morning, Chile. Good morning, Brazil. I'm pleased to present this work of my team today and in the International Conference on the Computing Science and its application. This presentation is part of the short project because where participate students of the degree and master degree, and Alexis and Alejandro are the part of the commission of revision of this job. For the reason we thinking that is a good possibility to the present in Congress, because this job or this project define the work to the step that some student or professional that work in logistic, because this problem is a generalization of the vehicle routing problem. We can see the general condition of the vehicle routing problem is minimize the cost. So for in different companies have different operation because they have shipping commodities to many customers, but you can it's necessary transport the commodities and different times and different days and different characteristic particularly to the customer. For this reason, the general problem is each consumer is visited exactly one time. However, in the case of the Brazil, for example, you need eyes to control the fruit in the coast. In Chile, in this moment, we have several problems with the um, climatic change. For this reason, some product is necessary transport not only in the morning. So in the morning, in the half day, and in the night, because we don't have the condition, for example, eye condition in every part whenever in a store. For this reason, the split delivery vehicle routing problem is necessary can explain that it's possible split the demand. But however, you can split the demand, but you can visit to the customer with different cars or with different vehicles. For this reason, this problem is very useful in the last mile of the logistic. So the mathematical models is not this very complicated. It's very similar to the a lot of the vehicle routing problem. However, the main difference is you need complete uh, 7 conditions, but you can read here. However, the more important is satisfies the demand because not is necessary satisfies the demand with one vehicle. For example, if you have and the event and the public event with a lot of people, however, the nano store to this for distributed the drink or the water or the beer, you need visit different in different areas and different times. For this reason, the routes is can be seen with a different vehicle and a different person to make this 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 route. For this reason, we have now the typical restriction of the subtour. For this reason, this problem is NEP hard. What say to this problem is NEP hard? You can find the optimal solution. However, if the problem is have over 20 customer, the problem explodes in the combinatorial combination. For the reason, it's impossible to find the optimal solution with the exact method. For this reason, you can define a heuristic or meta heuristic for your solution. For this reason, it's very important can instead the several steps to make the first solution for the logistic of the last mile, because in the in the industry of the logistic, not always you have the people with knowledge about the heuristic or the knowledge to make a particular program to make the distribution. For this reason, we define first step to make the study of this problem, and you can see the more important in this case is the validation and analysis. So the more important in this part, because we work with the student of degree, that this student of degree go to the industry that work in the last mile, in particular to the events with the high public. The instruction was, you need explain very well the the data truth that you need know for give and a good solution for this problem. That for this reason we define the several lists of client, and every and can explain how building the data you have and one client. In this moment, you can incorporate another data in this node, because you can define or incorporate the time, specific time you need visit, for example. So this is the first part of the job. Okay, so we define a methodology to separate the area of the study in 4 quadrants. So you can see here a little simulation. So for, in this case, you have the criteria where you can visit the most closer to the axis X, after you visit here, here, and here, because perhaps you have an arc to cut this distance. However, you can see that this way is on the first criterion to define the first routes. This is in the second criteria. Move this for C. For example, start more closer to the AX, after the more closer to the JX, sorry. So that this customer and this customer. So the criteria C is an criteria to the petal. You can see the arc for the returns is more closer to the the origins. So you with the capacity of the vehicles cut the demand. So so we define one process to the ensemble the routes, because we define in particular a circular linked list to make the first solution. So with this data structure, we find the better solution of the single list, because we go to the minimal solution. So every box is for every client. every vehicles. Okay, so in this moment, sorry, it's a video. Here you can see how define the different routes for the for the capacity of the vehicles. We split the demand of the different client. However, you can see that is possibly improvement this distance because you have this arc is very long. So in this case, we used the best now repair solution is the 2-OPT, is the Link-Kernighan heuristic. So hold this part of the route where you can find cuts in this part of the this route in green, you can find with improvement, and this way you we reduce the cost of this route. So we use with only 20 clients by criteria, and you can see with 20 clients and five track, you can see the number of clients you visit every track, the demand of average, and the capacity is used. For example, you can see in the track used very bad. Okay, it's very bad. It's very low. So the criteria B, you can see always the 5 tracks is low. Okay, but however, if the average demand is better in another track, okay, and after of this we increase the number of clients, we make experiment with this 120 client distribution and with good solution, but the criteria, the better criteria is the criteria C. Okay. Oops, 20 seconds. And we define 9 instances. Okay. We cover whole demand. Okay. So with those 2-OPT, you can see the total cost is very less after of the make of the algorithms of repair. Okay, well, 9 seconds. Sorry, and the second with the computational time is lower, is 1 second, and the proposal model we use less of 1 second for the reason we thinking that is a good solution. Okay. For finish, yeah, the constructive algorithms give the possibility to improvement the route because we define the 4 quadrants you can make and the rotation, because under rotation X, this way you can find better petals to make and the better roots. Oh, thank you so much. Sorry because I used it one minute more. For finish, this is an invitation to the artists to the next year in Chile. Thank you, Julio.
Thank you, Gustavo. Do not worry, you were even too much precise with time. Really, it was great. So
I'm sorry.
No,
50 minutes.
It's absolutely okay. So thank you for the good presentation. Is there any question from the public?
Hello, I would like to ask a question. Do you hear me?
Yes, Marvin, please.
Can you estimate the advantage that follows if you allow split delivery compared to if you don't allow split delivery? Can you guess a number like 1 or 2% or 20%? Is there some numbers?
The demand have and the comfort comportation comportation tiene una boo, the word boo. I lost the word in English.
Which word?
Is presented in the day in the different part of the day. For example, we have the first experiment. The first experiment we make with the benchmark of the literature. However, the another experiment we make with the data of the nano store that Santiago. For the reason we know the el behavior in the day. For example, we know in the morning is the 20%. In the half of the day is the is the more extensive consume, and the last of the day is less. For example, we have the data of the nano store. You can answer your question.
Okay, thank you.
No, thank you for your question,
Thank you.
Caspar.
And I also have a small question. It was about this rectification criterion you showed in one of the last slide, and it's similar to the one by Marvin. Can you estimate the advantage of using such criteria, or at least which is the reason for using the rectification technique?
No. The rectification technique always is necessary to reduce the cost of the transportation. For this reason, we know that, and the literature is saying that if you have routes with cruise, it's necessary open this arc for improvement the routes. So we have exit and delivery is the LKH. I don't know if you know, is the Halfun. You can share the link. I need the bottle of the whiskey for this person because use it for every heuristic in routing.
Okay.
I use it always because you make and the route and this livery and the problem and these routes.
Okay.
With the condition of time, with the condition of the capacity, with different problems. It's very, very good. So we use it for explain to the nano store customer with only cut 4 arcs. Okay, this livery had the capacity to split 6 arcs. For the 2 arcs, 4 arcs, and 6 arcs is in the combinatory very, very bigger. Very for the reason you have a lot of the combination. However, it's necessary explain to the distribution with the management of the operation. No, you need visit this client because if you go to the another part, you consume it and the X% or more of the fuel.
Okay.
We make sense and always try.
Okay. Thank you, Gustavo, again for your presentation.
See you. Now go to sleep.
Yeah. have a good sleep. You're from
See you.
Brazil.
Thank you. Thank you. Thank you.
Thank you. And Brazil and Chile. Sorry. There were lots of you from South America in this session.
No, the next year, wait here in Artis. This Artis is a congress is not as expensive for the degree student and the master student. The cost is less of the $200. With the volume in Scopus is a good congress. We wait here in Chile. I am the chairman.
Thank you.
See you. Thank you too much.
Again, see you. So, last call for the paper Computational Grid Optimization for the 3D higher order parabolic equation, which should be presented by Mikhail Litayev. I guess there is no one to present the paper. So I declare this session of the main track concluded for this morning. I would like again to thank all the speakers who intervened and all the people in the audience, of course. Hi, Edward. Thank you again for participating in this session. And we'll see you back in the afternoon for the next session of the conference. So thank you again and see you.
Thanks a lot for the chance.
Thank you. Bye.
Goodbye.